Hello, beautiful people. In this video, we are going to go through homework number 4 for Integrated Math 1. We're going to be talking about the segment addition postulate, midpoint formula, distant formula, angle addition postulate, angle relationship. So all of that is going to be in Chapter 8. Let's go ahead and get started with the segment addition postulate. So you want to do this in 3 steps. You want to do our setup, we want to do our plugin, and we want to do our solving. So it says find the lengths indicated must show your setup and your work. So for a setup, we're going to ignore all of the numbers. We're going to first start with our little pieces. So CD segment plus DE segment is equal to the endpoints, which are going to be C and E segments. That's step number 1. Step number 2 is going to be our plug-in. So we're going to be plugging in the numbers that we have. CD is 8. DE is unknown. You can call it X if you like, or you can keep it as DE. And CE, we can bring our fingers down here, is 15. So that's step number 2, your plug-in. Now step number 3 is going to be solving. So I'm going to be subtracting 8 on both sides, bringing down segment DE, and we have 15 minus 8, which gives us 7. For the next one, we want TU. TU is going to be this section right here. And we want to do this in 3 steps. We want to do our setup, our setup, our plugin, and then our solving. Now you can do all of your setups, or you can take a look and see which setups you need. So I'm going to take a look and see that I have TV. I need TU, but I don't know UV. So if I was to know UV, that could be helpful. Next, I could do different setups. I can do an ST. If I know what ST is, I know what SU is over here. So I'm going to do my setup. I'm going to just do a line here to split it up. I'm going to do my first setup as ST plus TV is equal to SV. So ST is here. TV is this guy, all of this, and that's going to be my endpoint SV. Now, the reason I chose to do this setup because we know what TV is. We need to find out what ST is, and we know what SV is here. So let's go ahead and do our plugins. ST is unknown. TV is over here at 15. And SV is at 23. Again, we're going to solve. So I'm going to subtract 15, subtract 15. We get 23 minus 15, and that gives us 8. ST is equal to 8. I'm going to put that in a thinking bubble. This is not our answer. This is not what they're asking. They're asking to find TU. So I'm going to do a secondary setup. And my secondary setup is going to be ST, so this one that we just solved for, plus TU, TU is the one we want, is equal to the endpoints here of SU. Then let's do our plugin. We do know what ST is. It is now 8. We do need to solve for TU. And SU, we bring down our fingers, we know is 18. Let's subtract. Bringing down our unknown TU, and that's equal to 10. And that's going to be our answer. Okay, moving on to the next one. This one's asking us to solve for x. So we want to stop and not plug it in anywhere. Let's go ahead and do our setup again. We got AB plus BC equals AC. Let's do our plugins. AB is 4 plus BC is 2x plus 3, and AC is 6x minus 1. Drop your parentheses, dotted line for balance, and our goal, our objective here is to solve for x. Combining like terms, I'm going to combine the 4 and the 3 together, making that a 7, bringing down the 2x. Here we have 6x minus 1. I'm going to be subtracting 2x on both sides. Again, bringing down that 7. Dotted line for balance, I'm going to extend that. 6 minus 2 is 4. We get 4x's. I'm going to add 1 to both sides, bringing down the 4x, adding here, and then dividing by 4. X is then equal to 2. And again, what did they ask for? They did ask for us to solve for x. So when you get that x value, you're done. If they asked you to solve for a particular segment, like they did in question number 1, make sure to use x and solve for that specific segment. Right, moving on. Still staying with that segment addition postulate, we're going to again do those 3 steps. We got a couple different more segments to write out. So we got QR plus RS plus ST is equal to QT. So that's our first setup. It is asking us to solve for x. So I'm going to see if that's enough because we can do kind of 5 total setups. I'm going to first check if this one is enough before I do the more setups. So QR is x plus 19. RS is 2x plus 21. ST is 8. Oops, not a plus here, equals. And QT, bring it down, is 18. So we kind of have to look and see, do we have just one unknown? And that unknown happens to be x. Everything else are just numbers. So that means, yes, this is enough for us to solve for x. So I'm going to put a dotted line here for balance. Drop your parentheses and combine like terms. Now here, combining like terms, we can combine our x's and we can also combine our constants. So we have an x here, we have a positive x here, and then our constants are going to be this positive 19, positive 21, and positive 8. So positive 19, I am using a calculator here off camera, plus 21 plus 8, I get 48, positive. And then 2x's plus 1 more x is a 3x. On the other side, I'm just going to bring down the 18, nothing to do with that. And then I'm going to be subtracting 48 on both sides. 18 minus 48, it is a negative 30. Bring down your 3x. Divide by 3, divide by 3. X is then equal to negative 30 divided by 3, a negative 10. Now, x can be negative. There's nothing wrong with x being negative. It is just a variable. It is an unknown. Now, a segment length cannot be negative. So if we were to say QR is negative, that would be not true. All right, let's go ahead and do this one. I did give you a little bit space. So we're going to have to do a couple more setups than just one. So let's go ahead and start with our main setup. And that's going to be ST plus TU plus UV. Now, my biggest hint here is make your V's pointy and make your U's with the tail. And that's going to be SV. That's our first setup. Then I'm going to take my finger, I'm going to cover the first letter. TU plus UV is equal to TV. Take my finger, cover the last letter. ST plus TU is equal to SU. Take my finger, cover one of the letters in the middle, so I'm covering T. So we got SU plus UV is equal to SV. And then down here, down towards the bottom, I'm going to take my finger, cover U, and that's going to be my final setup. ST plus TV is equal to SV. I'm going to take a moment here to draw my little segment bars here. Now, am I going to use all of these setups? Maybe, I don't know. but we have all 5 of them written out in case I need all 5. So what is it asking us? Well, it's asking us to solve for x. Okay. Then solve for all of the segment lengths. So that means I basically have to solve for everything. So let's go ahead and start by plugging in what we have. ST is 2x plus 27. TU is unknown. UV is 10. SV is 19. So if we take a look here, we do have multiple unknowns. So we have an unknown of x and we have an unknown of TU. So this one's not a pretty good setup for us to solve for x. TU is unknown. UV is 10. And TV, if we go down here, oh, hold on a minute. SV, if we bring our fingers down here, is not 19. That would be our TV. So I'm going to erase this right here. And I'm going to bring SV as just SV. This is going to be another unknown. I'm glad I caught that. So TV, take our fingers, bring it down. TV is 19. So we can continue. Absolutely, we kind of have to continue. But if we take a look here, I can already solve for the TU. So I'm going to wait on doing that, but that would be probably something we're going to do in the next few seconds. All right, ST is 2x plus 27. TU is unknown. And SU, where's SU? SU is x plus 24. Okay, next one, we got SU. We just did that one at x plus 24. UV we do know is 10. And SV, that was the one that I made a hiccup on. We don't know what SV is. So before I move on to the last setup, I'm actually going to pause here and work on this one that I mentioned. I'm going to subtract 10, dotted line for balance, on both sides because I see something. TU is then going to be equal to 9. Since we are trying to solve for each one, let me do a little equals here. Now that we know what TU is, I'm going to bring that TU here. And we're going to have TU as 9. And so what I noticed is that we end up having, let me bring down that ST and bring down that SU. And so what I noticed is that we end up having one unknown, and that one unknown is your X. So once we're here, I'm going to do dotted line for balance. Combining like terms is going to be that 27 plus 9. And that ends up being 36. Let me bring down that 2x. And bring down that x plus 24. I'm going to subtract x to both sides, giving me x plus 36 here and 24 on the other side. Subtracting 36, subtracting 36. X is equal to, now again, remember, x can be negative, but this segment length cannot be. So we get x is equal to 12, which is great because I kind of don't need this setup. I mean, I can use it, probably will use it, but I could just do many little setups here and plug in values for each of these values. So for our SV, I'm going to go ahead and plug in negative 12 for x, plus 24, plus 10, and that's going to be SV. And here, I'm just going to basically type this into the calculator, pressing enter once, so we get negative 12 plus 24 plus 10, and we get SV is equal to 22. Okay, what am I missing? I need an ST. So then basically this last setup, I didn't use it. And I'm going to create my own little setup. So ST is equal to 2x plus 27. So I'm going to plug in the x value of negative 12, 27, and then plug that into the calculator, pressing equals to solve. So 2, open negative 12, close it, plus 27, and we get 3. ST is 3. Okay, next one, TU. Well, we already solved for TU. Then we need to solve for UV. Well, that's 10. Then we needed to solve for SU. Did we solve for SU? No, we solved for SV. So SU is equal to x plus 24. Again, open up for x, put in that negative 12. Negative 12 plus 24. SU is equal to 12. Okay, which one am I missing? I think that's it. We got our SV, we got our SU, we got our ST, and we got our TU. So those are all of our segments. And then it did ask us to solve for x, so we do have that answer as well. Alrighty, let's move on to the next one. Alrighty, so this is our first question that's not with the segment addition postulate. This is going to be our radical section. Now remember, I did pass out to my class a memorization sheet where you need to memorize everything by the exam date. So we have our perfect. So these are just going to be quick. So the square root of 100, you got to know that that's 10. The square root of 144, you got to know that that's 12. So these are the perfect square roots. I'm not technically looking for expansions. I am looking for the answers without a calculator, okay? For your expansions, this would be 10 times 10 inside the house, and then our answer here would be without the house. And then we got 12 times 12 inside the house with 12 outside the house. And here we got 4 times 4 inside the house with 4 outside the house. Now these here, this is a little misleading, so I do want to clarify. You're not doing a calculator per se. You're not typing this into the calculator. So if I pick up a calculator and I do second x squared, so this is my square root, and if I type in 80, this is going to give me a decimal. This is not what this is talking about, okay? What I am referring to, yes, use a calculator, is if you need help with your expansions. So if you need to check 8 and 10, this is the wrong one, okay? Don't use 8 and 10. But this is what I'm talking about. And what you're looking for is let's type in 80. You're looking for a perfect square root to go into 80. So our perfect square root is 16. This is what you can use a calculator for. Do not give me decimals. You give me a decimal, I'm going to cross it out. So that means we got the square root of 16 times the square root of 5. Square root of 16 we saw here is 4. So our answer here is 4 root 5. Now again, you should not need to use a calculator here for your times, but if you need to multiply things to find out your values inside the house, you can. So for example, 108, we're looking for a perfect square root. So 4 is a perfect square root, but this is not our biggest. 9, also not our biggest. 16 does not work. 25 does not work. 36 gives us the biggest number here and the smallest number here. So this is why 36 is going to be our factor. So 36 times 3, which means 36 times the square root of 3. 36 square rooted is 6, so our answer is 6 times root 3. Okay, let's separate out 32. Again, we want the biggest one. I'm going to guess 16. Oh, there it is. So my guess of 16 did give us the biggest number here and the smallest number here. And so we're going to split that up. 16 times the square root of 2, square root of 16, is 4. So we get 4 root 2 as our answer here. Okay, make sure you have this memorized. No decimals. Big red flag if you give me a decimal. All right, let's go ahead and write out the distance formula. Distance formula is big square root here, x2 minus x1, quantity squared, plus y2 minus y1, quantity squared, take the square root, which is different than the midpoint formula. Midpoint is capital M, big parentheses with a big comma in the middle. We are going to be dividing by 2 for both the x's and the y's. We're going to take our x's, we're going to add them. We're going to take our y's, and we're going to add them. If you are choosing to use a calculator for your addition and division, make sure that you have parentheses around here and here. Step number 1 for A is going to be to identify our points. It doesn't matter which one you choose first. So I'm going to choose here at 2 and 1, 2, 3, 4, 5, 6 as my first point. And then here we get -6 and -5, 6, 7, and -8. You're going to label your points x1, y1, x2, y2. And it is asking us to solve for distance and for midpoint. So we're going to do that. Oops. All right. Distance, let's go and write it out. I am going to have to write just a tad bit smaller to make this work. So my setup usually looks like this. And then I'm going to write in my numbers. Oops. My x2, where's my x2? x2 is -6. My x1 is 2. My y2 is negative, hold on, my y2 is -8. And my y1 is +6. Take a look if you have any double negatives, which we don't. So then here is just going to be calculating the inside of the parentheses. Don't forget your squares. You can use a calculator for this section here, or you could just do this by hand. So -6 minus 2, that goes here as -8. Here we go, -8 minus 6, which is -14. Now remember, you do need to expand this here. If you are choosing to use a calculator, that's okay. Calculators will be allowed except for the answer. So open -8, close it, square it. That is 64. And in this step, the one that I'm writing, that's always going to be positive. Open, -14, close it, square it. And we got 196 here. We're going to add these. So 64 plus 196 is 260. And again, we do need to simplify this, okay? You do need to separate this out. And it does say, write your answer as a whole number or a fully simplified radical expression. No decimals allowed. So I'm going to type in 260 and I'm going to start dividing by pretty numbers that are perfect square roots. So 4 is a perfect square root. Now, if we take a look at 65, 65 cannot be simplified. Now, we can't keep checking. So you don't have to stop with 4. Sometimes it's wrong to stop with 4. But if you keep going, notice that none of the other perfect square roots give me an actual answer. 7 times 7 is 49. That doesn't work. 8 times 8 is 64. Also, that doesn't work. So the only number that actually went into, the only perfect square root that went into 260 is 4. So we're going to split that up as 4 times the square root of 65, which the square root of 4 is 2. So 2 root 65 is going to be our answer for distance. Moving on to the midpoint. Again, big M. Big parentheses, comma in the middle, divided by 2, divided by 2. Now we're going to be adding both the x's and the y's. So x's is 2 and -6. Y's are 6 and -8. Now again, you can choose to do a calculator here. So open 2 plus -6, close it. We get -4. We still have that divided by 2, the comma, the divided by 2, 6 and -8. Oops, open. 6 and -8, close it. We get, again, -2 here. We do need our parentheses. And again, here we get to divide. So -4 divided by 2 is -2. -2 divided by 2 is a -1. Put back your parentheses and your capital M for your answer. moving up. So we're pretty much doing the exact same thing here, except the points are already given, so they're not giving you in a graph. So let's go ahead and do exactly the same thing. X1, Y1, X2, Y2. Let's write out our distance formula. And again, my usual setup is open minus close squared and open minus close squared, and then I write in. Now, it kind of does help if you have your formula. So x2 minus x1 quantity squared plus y2 minus y1 quantity squared, take the square root. So that way it's easier to just look. So x2 is -5, x1 is 7, y2 is 6, y1 is -1. Notice how we do have a double negative here, so be careful. But if you are using a calculator, you can just type this in. I'll show you here in just a few moments how that would look like. Make sure that you still have your squares. So to type this into the calculator, open -5 minus 7, close it. This is -12. This is not our double negative. This one is. So we can add and just say it's 7, or we can do open 6 minus, which is going to be this button here, minus, and then -1, negative is going to be down here. Close it, and then we get our 7. Again, you can expand this with your pencil, with your brain here, or you can open -12, close it, and then this button right here is your squared button, and that's 144, and open 7, close it, square it, oops, no minus, that's 49. Add 144 plus 49, and that gives us 193. And again, we're going to check to see if we can divide into perfect squares. So 4 is a perfect square. What do we got next? 9 is a perfect square. So that's 3 times 3. 4 times 4 is 16 is a perfect square. 5 times 5 is 25 is a perfect square. 36. Notice how none of them are actually working for us. All of them are decimals. And that is because 193 actually cannot be simplified. So we're going to leave the square root of 193 alone. Okay, moving on to the midpoint. Big capital M, big parentheses, big comma in the middle, and a big 2 in the denominators. We're going to be adding our x's and adding our y's. So our x's, 7 and -5, our y's, -1 and 6. Again, if you are typing this into the calculator, make sure you have parentheses for your numerator. We get open 7 and -5, close it. We get a positive 2 here. Still have that divided by 2, -1 plus 6, close it. We get 5 halves. Again, make sure that you are simplifying. So 2 divided by 2 is 1. However, if you type in 5 divided by 2, that gives you a decimal. So leave that fraction alone as 5 halves. Simplify your fractions. So if you can make the number smaller, do it. But do not give me an improper or a decimal. Sorry, do give me an improper. Do not give me a mixed number or a decimal. All right, given the midpoint and one endpoint, find the other endpoint. Okay, so we're going to pick up this midpoint formula here. I'm going to write it off to the side. Midpoint is equal to, again, x1 plus x2 divided by 2, big comma, y1 plus y2 divided by 2, close it. Now, when you're setting this up, there's going to be 3 things that I want you to write down. I want you to write down given endpoint, missing endpoint, and midpoint. And you're going to do that for each of the questions. Now, the given endpoint is -5, comma 4. The missing endpoint, we're going to leave blank right now. And then the midpoint, hold on a second. Oh, there's a little typo. So this one right here is your midpoint. So I apologize for that if that caused any confusion. So this one's going to be midpoint as well. Okay, so let's go back to our missing endpoint. Now for the missing endpoint, you're going to be labeling the given and the missing. So let's go and label this x1, y1. So the missing endpoint is going to be x2, comma, y2, and it's always going to be the same. It's always going to be your x2 and that y2. So where's my pencil? There it is. Let's go ahead and use this setup. You're going to write out the midpoint. Here's your midpoint. And your midpoint is -10, comma, -6. Then you're going to do your x1, which is -5, plus x2, which is missing, divided by 2, and y1, which is 4, plus y2 is missing, divided by 2. Then you're going to have two setups, one for solving for your x and one for solving for your y. The trick is to use your fingers and to cover it. So I'm going to cover the second pieces. Gives me an equation of -10 is equal to -5 plus x over 2. Take my fingers, cover the x's, which gives me -6 is equal to 4 plus y divided by 2. Now solving this is very repetitive. You're going to start by multiplying. Here's your dotted line for balance. By multiplying by 2 both sides, all sides actually. And then we're going to say, okay, -20 is equal to -5 plus x. I'm going to add 5 to both sides. So x is equal to a -15. Put that in a thinking bubble. That is not your answer. Here we get -12 is equal to 4 plus y. Subtract 4, subtract 4. Y is then equal to 4, 5, 6, -16. Put that in a thinking bubble. That is not your answer. We're going to use those two here for your answer. Needs to have parentheses, needs to have a comma in the middle. Our x value is -15. Our y value is -16 for our answer. Okay, let's go again. Let's start with writing out the three English. We got given, end point. We got missing, end point. And we got our midpoint. Okay, again, our given endpoint here is -8, comma 8. Our midpoint is going to be 5, comma -3. And we got to label our points here. So x1, y1, x2, y2 for your missing endpoint. I'm going to look at this formula here for my setup. So we got 5, comma -3 is equal to, again, comma divided by 2, comma divided by 2. Okay, x1 was -8 and x2 is unknown. Y1 is +8 with y2 unknown. Let's go ahead and create our two setups. Again, using your fingers, go ahead and cover the y's. 5 is equal to -8 plus x over 2. Cover the x's. -3 is equal to 8 plus y over 2. Dotted line for balance, dotted line for balance. Multiply by 2, multiply by 2, multiply by 2, multiply by 2. We get 10 is equal to -8 plus x. I'm going to be adding 8 to both sides. X is then equal to 18. Thinking bubble, this is not your answer. 8 plus y is on this side. We get -6. Subtract 8, subtract 8. So 8, 9, 10, 11, 12, 13, 14. Negative here. And again, that's not our answer. Make sure to write your answer in the correct format. And that's going to be, what's our x? 18 positive, comma, -14 on the y's. Okay, moving on. Okay, moving on to angle addition postulate. So for the angle addition postulate, you still need to do your setup just like we did for the segment addition postulate. Remember, you're doing your little angle plus your little angle equals your big angle. So I'm going to go ahead and use my fingers here. So I'm going to put my thumb here, and that's going to give me my first angle. So the measurement of angle R, S needs to be in the middle. This is your vertex. T plus, I'm going to move my finger to the other little angle here. So that's the measurement of angle TSW is equal to, and I'm taking this and I'm covering the middle ray to give me my outer angle here, my largest angle at RSW. Okay, you need to have your little measurement symbol. So the measurement of angle RST plus the measurement of angle TSW plus or equals the measurement of angle RSW. Then you can look into the English and what it's actually telling you to do your plugins. So if the measurement of RST is equal to 50 degrees, and the measurement of RSW is 125 degrees, then the measurement of angle TSW is blank. So this is going to be our unknown, the measurement of angle TSW. And to find that, we're just going to be subtracting 50, subtracting 50. Now on the exam, you are going to be asked for a setup, the measurement of angle TSW, and your actual work. So 125, subtract 50, I'm thinking money here, 75. And you need to make sure to have your degree symbol. Again, if you don't put your degree symbol, I'm going to have to remove some points. So make sure it's there. Okay, let's go ahead and do our next setup. Looks like we have the same setup here and here, so we do have one of our setups here. So I'm just going to go ahead and use my fingers here. We got the measurement of angle RST plus the measurement of angle TSW is equal to, take your finger, cover the middle ray, the measurement of angle RSW. Okay, let's see what we have now. The measurement of RST is equal to 5x plus 20, and the measurement of TSW is 7x plus 10, and the measurement of RSW is 150 degrees. Looks like we only have one unknown, and that unknown is x, dotted line for balance. Let's go ahead and solve for x. Drop your parentheses, 5x plus 20 plus 7x plus 10 is equal to 150. Combining like terms, I'm going to combine the 5x and the 7. So 7, 8, 9, 10, 11, 12 x's. 20 and 10 gives me 30. Subtracting 30 on both sides gives me 120. Dividing by 12, almost ran out of space. X is then equal to 10. So we have x is equal to 10 here. Now they are also asking us for the measurement of RST and the measurement of TSW. Kind of don't have space here, so I think what I'm going to do is I'm going to just type it into the calculator. Okay, RST is 5, open, x is 10, plus 20. So we get 70 here. Now, here with this 70, you want the degree symbol because we are asking you for the measurement of an angle. So the measurement of an angle needs to have degrees. And then TSW, 7, open, 10, plus 10. And we get, again, 80 degrees. Make sure your degree symbol here. Do not put degrees on x unless it is an angle measurement. Right? This one here, I believe there's a typo here. Hold on a second. RSW, okay, RST and RS. Oh, yeah, I did the same. Hold on a second. Yeah, I didn't give you enough information. Let's go ahead and skip this one. So that's my fault and your benefit. So if this one gave you some trouble, I do apologize. There is a typo. Let's go ahead and skip it. Let's move on to our angle relationships. This one is complementary and supplementary. Now, complementary are angles that equal to 90 degrees. Supplementary are angles that are linear pairs. They could be linear pairs. They don't have to. Most of the time they are linear pairs, and that's going to give you the 180. Okay, so looking at this picture here, what do we have? Well, I see that I have two angles that form a line, so linear pair. What does that mean? Well, that means two angles form a line. Okay, what does that mean? Well, that means those angles are supplementary. And what does that mean? Well, that means they add angles to 180 degrees. And so this is your thought process here. Make sure you know all of that information. And then we're going to go ahead and do our setup. Now that we know that angles are going to be adding up to 180 degrees, we're going to have, again, take your finger, it helps with your finger, the measurement of angle DEF, no, just kidding, DEG, plus the measurement of angle GEF is equal to, cover that middle ray, and that's where your 180 degree comes in. If the measurement of DEG, 145 degrees, we don't know the measurement of angle GEF. Remember, you are going to be tested on your setup, so you can't just give me random answers, even if they are correct. You have to give me a setup. So I'm going to subtract the 145, subtract the 145. So the measurement of angle GEF is equal to 35 degrees. Again, we are talking about angle measurements. So only for angles do we need degrees. Okay, moving on. Still on that angle relationship for the complementary supplementary. Now, if we take a look at this next one, you notice that we do see a little boxaroo, and that little box indicates that we have a 90-degree section here. And because we have 90 degrees, we can do a setup. The measurement of angle A plus the measurement of angle B is equal to 90 degrees. We do know that this A here is 59 degrees. We are trying to solve for the measurement of angle B. We're going to, that looks like 590. It's not, that's my little degree symbol. Subtract 59, subtract 59. The measurement of angle B is 90 minus 59 degrees is 31 degrees. Make sure you have the degree symbol. We are talking about angles. Okay, next one, what do we have? Notice how we have a linear pair. How do we know this is a linear pair? Well, the angles form a line. And what does that mean? Well, that means those angles are supplementary. What does that mean? Well, that means that the angles add to 180. Okay, so all of that needs to be in your brain. Let's go ahead and do our setup. We don't have an A or a B. That's fine. So we can just go ahead and start with our work, with our plugins. We got, oops, that's a minus. We got one angle, x minus 16, plus the second angle of 4x plus 1, and that's equal to 180. Drop the parentheses, dotted line for balance, x minus 16 plus 4x plus 1. Combining like terms here and here, we get 5x, 16 negative, careful here with the negative, plus 1. That gives me a negative 15. Adding 15 to both sides. 5x is equal to 180 plus 15 is 195, dividing by 5. 195 divided by 5, oops, gives me 39. Now again, this one is solving for x, so you are not using degrees here. This is just an unknown variable. Okay, the next one is supposed to be tricky. It is supposed to get you to think because you have to pay attention to what you actually have. So here's your B, here's your A, and if you squint a little bit and pay attention, you're actually looking at this section right here. So what do you have? Well, that's a linear pair. How do you know it's a linear pair? Well, it forms a line. That pink line are your two angles here, your B and your A. So What does it mean to form a line? Well, it means that the angles are supplementary. And what does it mean to be supplementary? It means they add up to 180. So that means I'm going to skip the little setup. 97 plus the measurement of angle B is equal to 180. So that means if I subtract 97 degrees, we immediately get the measurement of angle B as 180 minus 97 as 83. Again, this is now a measurement of an angle. This now needs our degree symbol. Okay, for E, this one's asking you to solve for all missing angles. So do I want to right now? Yeah, that's fine. Let's go ahead and do it. Let's go ahead. I was going to skip it and come back to it, but that's okay. All right, let's go ahead and start with this 90-degree here. We know this box is 90 degrees. So immediately, 4, the measurement of angle 4, we know is 90 degrees. Now, if we have one box here, this means that right next to it, we also have a box because we have a linear line here, right? We have a line. The line is 180. If one side's 90, the other side has to be 92. But if we know that this is 90 together equals 90, I'm going to take 90, subtract 47 to get my angle here for 5 at 43 degrees. Okay, so if we have 90 here and I look at a different line, so let's look at this line here, vertically, up and down, a line is 180 degrees. So if I have this blue box, that means I also have this red box, meaning that the measurement of angle 1 is also 90 degrees. Now, this one here, this one you kind of have to think about. This actually goes through our next angle relationship, which is called vertical angles. So I'm going to go ahead and I'm going to draw this, I'll cover it up, that's okay. Okay. This right here, if you take a look, 2 and 47 do not make a vertical pair. They are not directly across from each other. They're kind of on a line here. Versus, if I was to cover this up, notice how these here, let's see if I can color code it for you. This 47 in orange and this 3 in orange, these are vertical angles. So we have vertical angles between 47 and 3, so measurement of angle 3 is 47 degrees. We can also say the same thing with the measurement of angle 5 and 2. So here's 5 and here's 2. These are also vertical angles. So that means that if I have 43 for the measurement of angle 5, across the street from it is also 43. Okay, moving on. Linear pair and vertical angles. So again, it is still asking us to solve for all of them. Okay, what do we have? Vertical pairs are going to be congruent, equal in measure. Linear pairs are going to be supplementary. So vertical angles across from each other and congruent. Linear pairs, they add to a line, which means they are supplementary. So let's go to start with the vertical pairs. So here's 28. And then we have directly across from it is our measurement of angle 2, which is again congruent, equal in measure. So we have the measurement of angle 2 as 28 degrees. Again, I'm going to skip around. Here's B. Here's my directly across from each other. Here, the measurement of angle 2 is 124 degrees. Now, for the linear pair, we're looking for angles that form a line. So I'm going to write in here 28 degrees. For the line, these are angles that add up to 180 degrees. So here we have 180 minus 28, and that gives us 152 for this angle. But again, we have vertical angles between 3 and 1. So this one we also know is 152. Okay, same thing here. Let's go ahead and draw out our line for our linear pairs. So 3 and 124 are linear pairs. Linear pairs are angles that form a line, which means they are supplementary, which means they add up to 180. So 180 minus 124 is 56. Now again, we do have those vertical angles between 1 and 3. Here's 1, here's 3. So if 3 ends up being 56 degrees, so that means 1 is also 56 degrees. Now this one here for C is asking you to solve for Y. To solve for Y, we're going to do our setup. Okay, what do we have? We have vertical angles. Okay, how do we know? Well, they're directly across each other, which means that they are congruent, which means that they are congruent, which means that they are equal in measure. And they are the angles. So that means our setup is going to be 4y minus 42 is equal to 2y. Dotted line for balance, and we are solving for y. I'm going to go ahead and subtract 4y on both sides. Bring down the negative 42. 2 times negative 2 times y. Divide by negative 2, divide by negative 2. Negative negative gives us a positive 21. It is asking us to solve for y, so we are done here. Okay, moving on. Just checking how much more we have. Okay. Solve for x, then solve for y. So this one you have to be careful. You got to take a look at what the relationship you have first. So I'm going to take a look at here, this relationship, and here, this relationship. What kind of relationship do we have? Well, those are going to be vertical angles. How do we know they are vertical angles? Well, because they are directly across from each other. What does it mean when angles are directly across from each other? Well, that means they are congruent. And what does it mean when angles are congruent? That means they are equal in measure. So 7x minus 2 is going to be equal to 11x minus 34. Dotted line for balance. Combining like terms here, let's go ahead and move over 7x. Bring down the negative 2. 7, 8, 9, 10, 11. That gives me 4 x's. Bring down the negative 34. Adding 34 to both sides. Bring down the 4x. 34 and 2 negative. So basically 34 minus 2, we get 32. Divide by 4, divide by 4. X is equal to 32 divided by 4 is 8. Okay, it is asking us to solve for x, so that part's done, but we also need to solve for y. So solving for y, we're taking a look at a different sort of angle relationship. And what angle relationship is that? Well, let's take a look. Here's your y, and if we draw a line to y, notice that we have, get it? If we draw a line to y, we form a line. So we have a linear pair. Okay, what does it mean to be a linear pair? Well, they're angles that form a line. Okay, well, what does it mean for angles to form a line? Well, that means they are supplementary. What does it mean to be supplementary? It means that they are equal to 180 degrees. So we get 18y plus 11x minus 34. That's equal to 180 degrees. But we just solve for x. We know what x is. So I'm going to go ahead and rewrite this 18y. But when I write out this x, I'm going to open up for x and put in that 8. Now, you have a choice to make. You could have done this off to the side and found out what that measurement is on its own. So I'm going to kind of do that as well. Type that into the calculator. 11, open 8, close at minus 34. That's 54. So this is 54. That means this is 54. You didn't have to put in x here. You could have done it off to the side and then use that 54 instead. It's up to you. It doesn't matter. Okay, let's go ahead and subtract 54. Let's make sure I don't run out of space. Looking pretty close here. 180 minus 54, that's 126 divided by 18. Y is equal to 7. So it is asking us to solve for x. It is asking us to solve for y. All right, let's go ahead and work on this one. Let's solve for the indicated angles. So I'm ignoring this. Please do not look at this right here. Ignore this. What you want to focus on here, find out your angle relationships first, and then write in things here. All right, let's go ahead and find out our vertical angles, so angles that are directly across from each other. So I'm going to have an angle here that's 50. That means directly across from each other. Here, that's also going to be 50. I'm going to have an angle here that's 22. So that means directly across from it is also congruent, equal in measure 22. Now, this one right here, you got to be careful. These are supplementary. We got 50, 50 here, 22 here, and I need another angle measurement here in order to add up to 180. So I'm going to type in 180 on my calculator, subtract 50, subtract 22, and that gives me that this angle is 108 degrees. But again, we have vertical angles. So if we know that this is 108, across the street is also 108 degrees. Okay, now that we have all of this figured out, let's go back here. Notice the difference between having M and not having M. These are names. So this is a name, this is a name, this is a name, and this is a name. However, here with the M's, these are measurements. So a name is not a number. A name is letters. So if it's asking us if it's asking us the angle BGC, let's find BGC. BGC, which is this guy right here, is congruent. We're going to say this is congruent to angle FGE. So no numbers here. Next, AGC. Let's find AGC. Hold on. Where's A? A little bit. Where's A? A is here. AGC. Okay. Here in gray, AGC. And that's going to be congruent to FGD. AGB, AGB, which is this guy where my finger is going to be congruent to angle EGD or DGE, doesn't matter. And the last one, CGE or CGE. So this guy right here is going to be, flip it over, congruent to angle BGF. And so now we're talking about measurements, which are numbers. So AGF, where's AGF? AGF here, we said was 22 degrees. Make sure you have degrees here. CGE, CGE. Oh, careful here. CGE is the combination of both of these. So 50, 60, 70. This is 72 degrees. This is D. DGE. Where's D? D, G, F. D, G, F are these right here. So that means I get 158. Next, we got DGE, 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 which is this little guy right here, so 50 degrees. BGC, BGC, which is this one right here, 108 degrees. And AGD, AGD, which is a straight line here. We know a straight line is 180 degrees. All right, beautiful people. I'm going to go ahead and create a part 2 for the review questions. Yes, the review, this part right here is part of your homework. You do need to answer these. This is going to help you for the possible extra credit questions on this exam. But this right here is the end of your Chapter 8 material. Thank you so much for watching. Have a great day. Bye.